Hi, hello, vanakkam, namaste to your channel Learning Legacy with your friend Siddharth here. So, our today's topic is very much famous. It is on photoelectric effect. Photoelectric effect is nothing but a phenomenon in which electrically charged particles are released from or within a material when it absorbs light or in the form of electromagnetic radiation. The effect is often seen as the ejection of electrons from a metal surface inside a glass tube in experimental conditions. You may see the pictorial representation of it too. As we speak about photoelectric effect, we may also see the experimental graphs that we received from comparing photoelectric current and the potential, the photo current and the stopping potentials at different frequencies of light. So we can clearly see, even though we change the intensity of the light, the stopping potential of the light remains the same. And even though we change the frequencies of the light, the saturation currents remain the same. So we clearly see lights of different frequency have different cutoff energy, cutoff potential. So let us see what does it give when we compare the stopping potential with the cutoff frequency. So it goes like the cesium's cutoff frequency is much lesser than sodium's cutoff frequency, which is much lesser than copper's cutoff frequency. So let us see them in values. The cutoff frequency of sodium is 5.5 into 10 to the power 14 hertz, which is greater than cutoff frequency of cesium, which is 4.6 into 10 to the power 14 hertz. The sodium's cutoff frequency is much lesser when compared to the frequency of copper, which is 11.4 into 10 to the power 14 hertz. So let us revise. For cesium it's 4.6, for sodium it's 5.5, and for copper it is 11.4 into 10 to the power 14 hertz. An important conversion to remember is 1 eV is equal to 1.6 into 10 to the power minus 19 joules. So when we just analyze the graphs that we just saw before, we may notice that even at zero voltage, we are getting photoelectric current. So photo current does exist even at zero voltage conditions. And the maximum kinetic energy of a photoelectron is dependent on frequency and wavelength, but not on intensity set by classical physics to be true. It is another classical mistakes from the classical physics in the quantum sphere. So for a particular light of wavelength lambda, the alpha, that is the photoelectric current, increases as we increase the intensity, but not the cutoff voltage. As we saw in those graphs, the cutoff voltage doesn't increase or decrease while you decrease the intensity of light. It remains same. Photoelectrons are emitted simultaneously irrespective of the intensity of incident light. Number of photoelectrons emitted is directly proportional to intensity of light. Now here the common doubt we would have is we are saying that number of photoelectrons emitted is proportional to intensity of light. But the photoelectrons are emitted simultaneously irrespective of intensity too. So here let me make it clear. The amount of electrons released may be affected by intensity, but intensity of light cannot affect the whole process of emitting electrons by the material. Yeah, sure, the number of electrons which is released by the metal perfectly depends on the intensity of light. That is good. That is true. But you can't stop the process of the material which emits electron from it, even by absorbing small quantas of energy from the photon. So I hope it's clear, and we will move on to Einstein's photon theory. So Einstein told there is no such thing called like quanta or something, and he proposed a particle called photon, which had energy same as the quanta, that is h mu. And he stated that maximum kinetic energy of the electron is equal to the photon energy minus the amount of energy that is required to take it out from the metal. That is the work function. So this leaves us with h mu is equal to the maximum kinetic energy, that is half v max square plus phi. That is the work function that we have. So this is called the Einstein's photoelectric equation. So here we need to understand the work function is directly proportional to the cutoff frequency. So it obviously affects the whole thing. So cesium will have less cutoff frequency than sodium and then Cu. So as you may guess, the work function for cesium is 1.9 electron volt. For sodium it is 2.3 electron volt, and for copper it is 4.7 electron volts. So energy of photon, as we remember, it is h mu. That can also be written as hc by lambda, where c is speed of photon and h is the Planck's constant. So if we simplify them, we get energy of photon is equal to 1.24 into 10 to the power 6 by lambda electron volts. So that's it for today. I hope you guys enjoyed the lecture and would have got some extra information to learn. So that's it for today, guys. Hope everything was clear today. We'll meet with another great video in another great day. If you like the video, please like, share and subscribe. It is Learning Legacy. It's where your legacy for learning begins.